Okay. So this is the 23rd question, by the way. Can Ibrahim, can you read the question, please? Yes, Ibrahim, nearby.
Explain what is meant by the capacitance of a parallel plate capacitor.
Acha, we discussed this concept, okay, that it is basically the ratio of the charge stored on any one plate per unit potential difference across the plate. Okay, they are giving you 3 mark for that. Okay, so this is the definition. We wrote that in the paper. Okay, just move on, please. Where are you?
Three parallel plate capacitors each have capacitance of 6.0 uh,
Cool, Farad.
microfarad. Draw circuit diagrams, one in each case, to show how the capacitors may be connected together to give a combined capacitance of 9 microfarad.
Okay. So we have three capacitors, okay? Everyone is 6 microfarad, okay? So we have one possibility that we can draw every capacitor out, okay? So the first possibility is connect all of them in series, okay? But the second one is connect all of them in parallel, okay? The third one is connect two in series and one in parallel. And the last one is connect one in series and then two in parallel, okay? These are the four possibilities for these three capacitors to be uh, combined. Now let's try to figure out what will be their capacitance. Okay, so
Uh,
mhm,
I think it's a fourth one. The
last one,
one in series and two in parallel.
parallel. We know that the parallel capacitance are usually added. So 6 and 6 get 12, and then 1 over 6 plus 1 over 12. Okay, so 2 times 2, and then that become 2 over 12 plus 1 over 12. That gives me 3 over 12, 12 over 3, 12 over 3, and that gives me 4. Okay, so I'm getting the capacitance, the overall capacitance as 4 from the last circuit, which means this is going to be for this one. Okay, right? This is going to be for this one. Mm-hmm. Okay, so this one and this one. Okay, circuit done. Now, what about the first one? Okay, we want to make 9 microfarad of capacitance. Yes, which one is possible? So three, okay. So 9 means if we add all of them, so that gives me 18. Okay, this one gives me 18. 1 over 6, 1 over 6, 1 over 6, 3 over 6, 6 over 3, 2. That gives me 2 microfarad. Okay, this is 4, and that should be 9 then. Okay, so 1 over 6 plus 1 over 6, 2 over 6, 6 over 3, 2, 6 over 2, 3, and then 9. Okay, clear? Guys, that clear? So I'm getting this one. Mm, one in series with other one. Okay, and they both are in parallel. They both are in parallel. Okay, come on. Okay, moving on to the next question. Okay, so that is completed. Now, yes, Ibrahim, can you please read?
Two capacitors of Capacitances 3.0 microfarad and 2.0 microfarad are connected in series with a battery of electromotive force 88 volts as shown in figure 6.1.
Hmm. Okay.
Calculate the combined capacitance of the capacitors.
So the combined capacitance will going to be 1 over 2 plus 1 over 3, right? Because in series you just 1 over 2, 1 over 2 plus 1 over 3, okay? And then 3 to 5 over 6, 5 over 6, okay, is 1 over C total, and then that gives me 6 over 5, 1.2. Okay, please move on. So they are saying that.
Use your
Mhm.
answer in 1 to determine for the capacitor of capacitance 3 microfarads the charge on one plate of the capacitor.
Okay. So the charge on one plate of the capacitor means like you have to find out the whole charge. Okay, in the circuit, we know that this is a series circuit by the way. Okay, and in series circuit, whatever the total charge will be, the charge remains the same in every component, right? So, if we find out the total charge, so Q is equals to CV. Okay, and then 8 divided by 1.2 um gives what? Sorry. So I have 3 microfarad of capacitor, okay, and then V V is terminal charge for, but we don't know the V. Okay, problem. We have the overall capacitance. The overall capacitance give me the overall. Yeah, come on. Overall capacitance is 1.2 microfarad, and overall voltage is 8. So that gave me that. Bro, this is what we have to do. So 8 ones are 8, 8 twos are 16. One carry, so 9.2, 9.6 microfarad. Okay. Then the charge is stored. Ouch. So 1 over 2 into, you can if you use CV square, so CV square will be problematic. So, and if you use Q square over 2C, then that will be easy, right? Because we have the 3 microfarad capacitor. Okay, and we know the charge 9.6 exponent negative 6 joules. Okay, divided by 2 into C हमारे पास C is C is 3 microfarad. Okay, 3 exponent negative 6, right? Because for this one we are finding the capacitor of that energy stored in that capacitance, but in the previous part we were finding the total charge in the circuit. Okay, and that total charge will be same as a charge in any one capacitor because they are both connected in series, right? Now please move on to this question. Okay, so they're asking for the functions. They're asking for the parallel plate capacitor. We already done that. The functions are like the same, where you write the energy storing, or or where they use as the smoothing element. Okay, and they can use as tuning circuit in the tuning circuit or in an oscillator circuit. Okay, so or you can use it to block DC. These are the functions. Okay, now please, Irfan, read the question, please. Yes, Irfan, nearby. Basically, they are saying a student has available four capacitors, each of the capacitance 24 microfarad. The capacitors are connected as shown. Okay. So basically, these three are in series, okay, with the one capacitor because they don't have any junction. The current will follow the straight path, okay, without going into any other direction, okay. So we have to find out the combined capacitance between X and Y. So that is going to be 1 over 24, okay, plus 1 over 24, okay, and plus 1 over 24, okay. These are for the three capacitor in series, right? 3 over 24, 24, 3, 8. So see, so total for the first capacitor is 8. Okay, and then the other one is in parallel with that. So total capacitance will be 8 microfarad plus plus what? Plus 24 microfarad. So that gave me 32 microfarad. Okay. Now another question asking the same thing. Okay. Acha, by the way, they have given you three capacitor in most of the questions they are providing you with some of the capacitors, right? So if you have three capacitors, then always keep in mind that you will have certain probabilities, okay? Like either you can arrange the three capacitor in series or three capacitor in parallel, or you can arrange one in series with the two in parallel or two in series with one in parallel, okay. These are the simplest four scenario. You can just put four things, put four circuit like that, and then you can solve, right? And moving on to by the way, there's the electric field graph. Radius, they're asking for the radius, so radius is going to be 2.1. Calculate the charge sphere that required the electric field concept, which I'm not talking about. Okay, we can say that. So K electric field is equals to K Q over R, right? And since we are interested in charge, and let's say we are taking the first value, which is 1.3, okay? The electric field value is 1.3 exponent 5. This is the value at the radius of the sphere. Okay, and R is going to be 2.1 exponent negative 2, right? Divided by 8.99 exponent negative 9. This value will be given in your exam first page. Okay, so you will end up getting 1.3 exponent 5 into 2.1 exponent negative 2, or divided by 8.99 exponent 9. So I am getting the charge value as 2.9 exponent negative 8. Okay. So this is the value. Okay. Use the formula for the electric potential due to the isolated point charge. Determine the capacitance. So they're asking you to apply V is equals to, sorry, C is equals to 4 pi epsilon naught R. Okay. This is the formula to find the capacitance. Okay. 4 pi epsilon R capacity 2.21 exponent negative 2, right? And then you have mm, 2.1, eh? Okay. So 2.1, 2.1, okay. And we have the radius done, pi done, and epsilon has a value of 8.85, negative 12, okay. So I'm getting the capacitance value as 2.3 exponent negative 12. तुम लोग क्या आ रही है? You guys are getting that? चलो. अब आज इस वाले क्वेश्चन को लेते हैं quite different than the rest of the type of the question. Again, they're starting the question with a similar concept. Now, in part B, they're saying a capacitor of the capacitance is connected into the circuit. Okay, And when the two-way switch is position A, the capacitor is changed so that the charge, so that potential difference across it V. Okay. Okay, which means अगर कैपेसिटर इतना चार्ज हो रहा है potential difference across it completely V, this means कि capacitor will get fully charged, okay, in this circuit, okay, and that fully charging will like it is a point till when the charging or the charge flow will be zero, right? This is the process of the charging, okay, or this is how long the charge lasts. Okay, then the switch capacitor is changed so that the potential difference is at V. The switch moved to the position B and the capacitor fully discharged through the sensitive ammeter, okay, which move repeatedly between A and B, so that the capacitor charging then discharge with a frequency F. Okay, so this is the discharging of the capacitor with a frequency F. Q equals to IT. Okay, in place of and Q is equals to C over V. Okay, in place of I. Okay, and then so FT, we have to remove Q equals to IT and Q equals to, wait, something's not correct. Q equals to IT and then Q is equals to I over F, right? And then over here, Q can be replaced with I over F, and then F can go to the other side. Okay, so they have given you the voltage, the frequency, and the current. You can find out the value of the capacitance in okay, let's find out. And we have 4.8 exponent negative 6, right? So when you multiply, you'll get the capacitance. Wait, we won't get the capacitance. We get okay, by the way, the current should be in this side, 4.8 exponent. Okay, let me just calculate 4.8 exponent negative 6 divided by. I'm getting the value of 5.333 exponent negative 10. Okay, now a second-hand capacitor has same capacitor as connected into the circuit. The two capacitors are connected in series. So you know that capacitor, adding the capacitor in series will reduce the overall capacitance because in series the capacitance is smaller than the actual than the individual capacitor. And in parallel, it's vice versa, right? So we can say that the new reading would be half of the original value, okay, which is if this one is 5.3, then the other one would be less. Exactly, you can divide that by 2 to get the value. Okay. By the way, they're asking it in picofarad. So picofarad should be 530 picofarad, right? And the total capacity should be half. So that gave me, by the way, reading should also get halved. Okay. So 4.8, so 2.4 only chahiye, 2.4. So let's bring the new reading. Okay. We can say that since total capacitance is half. Okay. So the the charging and discharging will also be half. Okay, and if they're half, so charge will be half. Okay, or current will be half. That they have, so that the current, wait, will be, come on, will be have to, will be half. That's it. Okay, now moving on to the other circuit. Okay, or the other question. Good one. Okay, so let's try it together. So the question says that you have two flat metal plates are held in a held a small distance apart by means of insulation pads, as shown. Okay, explain how the plate could act as a capacitor. Okay, so because you can say that both the plate will the potential difference across the plate causes the plate to store the charge, oppositely charge of equal amount. So this is how they can act, it can act as a capacitor. Okay, the PD across the plate. Come on, stores charge. Okay, so the PD across the plate stores causes to store charge. Okay, that's it. Okay, now the potential difference that causes the store, or you can say that causes the store of energy after charge separation. Right, that's it. Okay, moving on to the next part. They're saying that the arrangement in the figure 6.1 has the capacitance C. The arrangement in the the arrangement is connected into the circuit. Okay, so we have two-tone switch. It can either go to A or to B. Okay, for charging and discharging. Okay, and when the two-way switch is moved to the position, the capacitor is changed so that charged so that the potential difference is V. Okay, move to the position fully discharged through the center. Okay, the switch move repeatedly between A and B so that the capacitor charge and then discharge with the frequency F. Okay, show that we have shown it already. Okay, Q through ID and then Q is equals to I over T, I over F, and then Q is equals to CV. Substituting everything, I'll get I is equals to CBF. Right. Now you can find out, okay, these are the easy one. Okay. Trying the last question, then the rest will be your homework. Okay. Now, so in this question, ouch, wait. Mm, charging. Um, okay, so basically In this question, they are saying that the capacitor consists of two parallel metal plates separated by the air at a variable distance. Okay, x apart as shown. Okay, the capacitor C is inversely proportional to x. Okay, we did this formula. C is equals to mu naught A over D, right? And over here, D is basically A, D is basically X, right? So what they mentioned, okay, because it's not a part of syllabus, so that's why they're mentioning, okay? Now, the capacitor is charged by the capacitor is charged by a supply so that there is a potential difference between the plates, okay? State an expression in terms of CB for the charge Q on one of the plate and for the energy E stored on the other plate. Okay, fine. So you can say that Q is equals to CB and 1 over 2 Q into or CV squared or Q into V. Okay, these are the two possible formula. You can rearrange it to any form. Okay, now they're saying that the capacitor in the circuit, the charge in the capacitor is now disconnected. Okay, the plates of the capacitor are initially separated by the distance L. They are now moved closer together by the distance D as shown in the figure. Okay. Now, the original position, now the new position. State and explain the variation in term of C, V, L, and D for the new capacitance. Okay, we know that the capacitor they're related the capacitor with C is inversely proportional to X. Okay, or we can say that C1 X1 is equals to C2 X2. Okay, this is what they mentioned over here. Okay, and we are using that now. Previously the capacitance was just C when the distance was I think X or L, basically L, right? Now for the new capacitance, okay, for the new capacitance, mm, for the new capacitance C new, we have to find out X2, okay, which is going to be L minus D, okay, L minus D, because the distance should be in between the two plates, okay, it's not outside, okay. Now, so C new is going to be CL divided by L minus D, okay, CL divided by L minus D, okay. Now they're saying the new charge on one plate of the capacitor. Okay, so that is the new capacitance. Q equals to CB. Okay, and if I can say that in place of C, if we just CN. Okay, the new capacitance on one of the plate. Wait, it should be same. There won't be any change, because you're just moving the plate together. You're not connecting it outside the circuit, or you're not connecting the capacitor with any other thing else, right? So I think this would be the final answer. Okay, now they're saying the potential difference we knew between the plate. Okay, so the new capacitor and the new charge and the old charge remains same, while the capacitor and the voltage changes. Okay, we know the new voltage, right? If we apply Q equals to CV, right? So Q new and Q old remains the same, right? While C new is going to be okay, that is basically CV, and C new is basically CL over C minus D. Okay, CL minus divided by L minus D. Okay, and then we have V over here. Okay, what? V is getting cancelled. We have to put the new V over here because okay. Now this C and that C goes off. Okay, and we'll be left with um L minus D over L. Okay, and then V. Okay, is equals to V new, right? So this is a simple thing, right? So there should be N new, C new, and then V new. Okay, and you have to put every new values in it. Okay. Now the last part says explain whether reducing the separation of the plate results in increase or decrease in the energy of the separation. So we know that if you move in the direction of field, then you will going to lose energy. And if you move against the direction of field, then you store energy, right? Now, if imagine if let's say you have two plates, okay, one in this direction and other in this direction. Let's say the first one is positive and the second one is negative. So the electric field should be in this direction, right? But if you make the plate closer to the second plate, then basically there the plate is moving in the direction of field, okay? And this makes or this reduces the energy, right? Because you're moving into the plate, right? In the direction of field, right? Since charged particle attract each other, okay? Um, and moving the plate in the direction of field will going to reduce, right? So this is the concept, and that is the last question, and the rest is easy, right? Now I'm ending the class right here, okay? And the rest is your homework. I've sent this workbook on the group, okay? So just try as many questions as you can, and then we'll move on to the new chapter. Okay, the remaining part of this chapter from the next class, okay? Okay, guys, that's it. That's it for today. We'll meet you guys not tomorrow, but we'll meet you guys on the next week, but Friday, okay, not Saturday. If the timings got confirmed, okay. So yep, okay. Till then, take care, guys. Enough is.
Dolphins.
Yes.